Hello. We are going to look at solving one-step equations. The best thing about these equations is because of their name, they will literally have just one step that you need to do before you can solve them. We'll look at a couple of examples. As we go, I want you to keep in mind of this, there it is, inverse operations. We know that an operation is add, subtract, multiply, and divide. Inverse would mean simply the opposite. So you'll hear us talk about that, the inverse operation when you're solving an equation. First one we're going to look at is this purple equation. I would read this as 3 plus x equals a negative 7. Now, we can also replace the x and write something equals negative 7. So I'm trying to find what it is when I add it to 3, I equal negative 7. Now, one thing that people forget to do is not read it out loud. By reading the problem out loud actually allows your brain to kind of think through the problem more so than if you would have just left it on paper. What I like to do is what I call the wall. Put it right down through the equal sign to remind myself what I do on one, I must do on the other. Since this is a positive 3, I simply then, to make this get x by itself, I'm going to do the opposite or the inverse. I'm going to get my equal sign. Positive 3 minus 3 gives me 0. That's what we want. All I'm left with then is x on this side is equal to, then we need to do some subtracting. Negative 7 take away 3 more gives me a negative 10. This would be my final answer. Of course, you can always check your answer to see if you are correct. 3 plus a negative 10 should equal a negative 7. And it does. A negative 7 equals negative 7. Look at the second one in green here. I have a negative 3 plus x, or plus something, equals a negative 7. This is very similar to the first one. And it looks again like it's going to be adding. However, if I slide it down here, over here you notice there's a positive 3, and this was a negative 3. I'm going to rewrite this green one as a blue equation, and I'm going to flip these two around. I can do that if I keep the signs with them. The negative stays with the 3, the plus stays with the x. So I know this is going to be a positive x. I'm going to see a minus 3 equals a negative 7. So now you can actually see that you're taking away 3 already, which means if I'm drawing my wall, that the opposite or the inverse would be to add 3 to both sides. On the first equation, we took away 3 because this was a positive 3. Here we're starting with the negative or subtracting it, and therefore I'm left with, this cancels out, just x over here, and a negative 7 plus 3 is negative 4. Again, we'll check our answer, make sure it makes sense. Negative 3 plus a negative 4 is equal to a negative 7. On this side, I get a negative 7. Over here, negative 7. All right, so those are adding and subtracting one-step equations. Let's look at this next page. Again, you'll see the inverse operation. I read this one as 5 times something equals 65. Remember, when a number is right next to a variable, it does mean multiply. So if I slide this down, let's show you how. Whoops, slide it down. I would go about solving this. Again, you can leave your wall. And then as I'm going through solving, instead of 5 times, you think the opposite or the inverse would be to divide. I write it like a fraction. Divide. Over here, we know that 5 on top of 5 is in fact just 1. So it almost just cancels out to 1x is equal to, well, we got to reduce this fraction. 5 goes into 6 once. There's 1 left over. 13. Let's check our answer. 5 times 13 should equal 65. And 65 equals 65 then. You'll notice what I'm writing on the left side, I stay on the left, and the right side stays on the right. Let's check out this multiplying problem. 2/3 times something is 9. Again, this is multiplying. With fractions then, we wanted the whole idea is to try to get it down to just 1x. Over here in this first equation, I divided by 5. Here's my 1 right here. In order for me to change this 2/3 into 1, think back to your fraction days. 2/3 times what gives me 1 whole? Well, it's its reciprocal. When you're doing a fraction problem, you actually multiply by its reciprocal. 3 times 2 is 6. 2 times 3 is 6. 6 over 6 is 1. So we've actually canceled it out. I'm just left with x equals, now don't forget my wall that I'm drawing here. Over here in green, I times it by 3 over 2. I also have to times this, whoops, stay color coded, by 3 over 2. Okay, if you remember your fractions, both numbers must be a fraction, so make that 9 over 1 times 3 over 2, and I end up with 27 divided by 2, or 27 over 2. We can then simplify that. 2 goes into 27. Let's see, well, 2 goes into 2 once. 2 goes into 7 3 times, and there's 1/2 left over. 13 1/2, or 13.5. Okay. Finally is an equation that looks like this, almost similar to this guy, whereas there's a fraction. I would read this equation as something divided by 4 is 12. A common mistake is for kids to say, oh, x equals 3, and circle it, because they see the 4, they see the 12, they see it divided. This is a big, big no-no. Let's see, what can I do? Creative pen. Oh, this is a good, I'm going to spray paint this. No, x does not equal 3. Let's try for real now. Okay. So if I take this guy, same type of thing, if I hear it and say it out loud, slide it over so I can write on it, is x divided by 4. There you go. Did you hear it? What would be the opposite or the inverse of dividing? Yep, multiplying. So let's multiply by 4, and in this case it would be 4 over 1. Again, there's, you see your fractions. We get 4 over 4, which just ends up being x equals, multiply by 4. In this case, I only have to do times 4 because there's not a fraction. 12 times 4 gives us our answer of 48. Let's check this one. 48 on top of 4, does that equal 12? Well, 48 simplified, 4 goes into 4 once, 4 goes into 8 twice, that equals 12.